Okay, you should look at question 1 from the February 5th, the 0205 file, if you haven't already done so. The first question then is we roll 2 dice. If we roll 2 dice, what's the probability that we're going to get a total greater than 4? Okay, well, first thing you want to do, hopefully first thing that occurred to you when you saw that we're rolling 2 dice, would be to list the sample space, or one way or another. Now the easiest way to list the sample space, the quickest way, is to simply make a table. Outcomes 1 through 5 here, 1 through 6, outcomes 1 through 6 here, and that leads to totals. 1 and 1 is 2, 1 and 2 is 3, etc. We've been over this sample space previously. And also note, you could represent this sample space by tree or by a listing. You should be able to do it in any of those ways, but we're going to use this particular way. If you have another way of listing it, either through a listing or through a tree, you can answer the question based on the listing or the tree just as well. But you have a little better visual representation of the sample space here. So we're looking for outcomes greater than 4. Where are the outcomes greater than 4 on this list? Well, they go from here down. The outcomes 4 or less are from here up, as you can easily see. And you can easily see then that the number of outcomes for a result greater than 4 will be the 36 possible outcomes, which is the 6 times 6, there are 36 numbers here, less the 6 numbers you have up here, leaving you 30 numbers that are greater than 4. So there are 36 possible outcomes. 6 are less than or equal to 4, and therefore 36 minus those 6 equals 30 will be greater than 4. Now the probability of a total greater than 4 then is what? Well, 30 of the 36 possibilities, 30 of the 36 members of the sample space are results greater than 4, so that you would think, well, it would be 30 out of 36, and that's exactly what it is. Now, if we write a probability, the formal definition is the number of outcomes favorable, which would be the number of outcomes that are greater than 4. Those are the outcomes that are favorable to the condition, divided by the total number of possible outcomes. And again, that's 30 out of 36. That reduces to 5 out of 6. That can be expressed as a decimal, 0.8333 repeating, or if you prefer, 83 1/3%. Now, we did in class, we rolled 2 dice 10 times. How many times would we therefore expect to get an outcome greater than 4? Well, if there's a 0.83 probability or an 83 1/3% probability, we expect to get greater than 4. Then we expect to get greater than 4 on 0.833 times 10 trials equals approximately 8 trials. Well, we actually did this. We actually rolled the dice, and this is exactly what we got. Now, we could have easily gotten 7 or 9 or even 10 or 6 times. It wouldn't be that improbable. It would be pretty improbable that on 10 trials we would get, let's say, the same result, let's say 2 on all 10 trials. There's only one way to get a 2. That would be quite unlikely. But, or we would not expect to get numbers greater than 4 on only 1 or 2 of our trials. That would also be unlikely. Now we also look at the idea of odds. Odds are a little different than probability, and they're often confused. So we want to make sure we understand from the very beginning the distinction between odds and probability. The odds of getting a number greater than or equal to 4 are what? Well, we say the odds are the number of ways to get a number greater than, and I've got greater than or equal here, it should be greater than. Odds of greater than 4, number of ways to get greater than 4 to the number of ways to not get greater than 4. Well, how many ways are there to get greater than 4? There are 30. How many ways to not get greater than 4? Well, that would be the ones that are less than or equal to 4. There are 6. So the odds are 30 to 6. And if we divide both these by 6, that gives us odds of 5 to 1. Now, odds are important if you're looking at betting. For example, if you were betting $1 that we would get a number greater than 4, then, or if you were betting $1 that we would not get a number greater than 4, then we'd have an equal and fair game if I bet $5 that we would. And you can think of how that works out. We'll talk about that more when we talk about expected value toward the end of this chapter.